Yeah, hello everyone. Today we understand what load balancer is and what problem it solves. Imagine you have an application running on a single server. Please note here that every server has a limit on how many concurrent requests it can handle. Okay, and suddenly you million of users start sending requests to the same server. That single server will now slow down or even crash due to overload. So the problem here is too many users, single server. So the problem, a single server cannot handle massive traffic. So to solve this, we don't rely on single server. Instead, we use multiple servers so that the traffic get distributed across multiple servers. But then the question is, how do we decide which request goes to which servers? So the answer is load balancer. This is where load balancer comes into the picture. A load balancer sits in between the user and the server. It receives all the requests and distributes it to the server. Okay, you can see this diagram. This is a client application. This can be a browser, and these are all your servers. And this is a load balancer. It is sitting in between the client and the server. So now instead of sending request to only one server, the load is shared across many servers. Okay, these are the multiple servers. Okay, so how it works is user sends a request. The first request comes direct, it will not go directly to the server. It first comes to the load balancer. Load balancer forwards the request based on the strategies that it's defined to the servers. So there are two types of strategies that are more common. One is round robin and another one is a least connection. Round robin is most commonly used. How it works is first request goes to the server 1, second request goes to server 2, third request goes to server 3, and so on. Okay, and it will keep cycling. Then again, suppose if you have 3 servers, then after fourth server will again go to server 1. Least connections. So here the server with least connection load, that means that their server is minimum have an idle time, will get the next request. What so this result gives you a better performance and high availability. This improves the performance. Okay, and also it makes sure that even if one server is down, one server goes down, others can still handle the traffic. Okay, let's see this in action using a simple Node.js example. Okay, so here you can see as per the diagram, we have two things, server and the load balancer. So this is a load balancer code, and this is server code. This is server, a simple express server where I'm just starting 3 servers. This is in order to give you a demo on the local, so we cannot start 3 server on same port, but in the production ready application all 3 servers will have the same port. Okay, so in my local for the demo purpose I'm using different ports, 3001, 3002, 3003. It's a simple express no express JS code that used to route the APIs. So this is the one route that if you navigate to slash, you have to give just response and will tell you from which server is uh, giving you the response. That is we are just logging that request. Okay, let's go to the load balancer code. Load balancer code, here I have implemented round robin algorithm. We have 3 servers registered, so it is important that load balancer knows how many servers are there registered with him. So first we have to tell them that okay, these 3 servers are registered. Then it's just a simple for loop. So request will come first to the uh, load balancer, and load balancer will just forward. So I have written here forwarding to the target. So here it will just forward the target http get, and this is the target URL, and then target URL of the server 123 based on that. So this will be decided on the round robin index, and whatever data we are getting back, we are just printing that data in the browser. Okay, so for example, for now I'll start this load balancer on 3000. Okay, just a minute. you can see our load balancer is started. Now I'll just start the server. Similar way, we have the server in the same folder. See, 3 servers have started. Okay, this 3 server. Now I'll just give you a demo of how it will work on when a client requests it to the load balancer. Okay, so here you can see http localhost 3000 is our load balancer URL. We will be hitting that URL. Okay, so this is what you are getting. You are getting response from server 1. If I hit again, then again you are getting response from server 2. If I hit again, then again you are getting response from server 3. Then again it round robin fashion. So again it went to request server 1. Okay, okay. So this is how every request will be handled by different server based on the round robin fashion. So on every refresh, the request is forwarded to different server. This is round robin and load balancer in action. The client does not know which server is, so we have written here console, but client actually does not know which which server is handling its request. The load balancer abstracts everything for you. So this is how, sorry, so in the real world example also, this is how large systems like websites and API handle millions of requests. Okay. As I've told earlier in this, so every server has a limit on how many concurrent requests it can handle. So you will be having a question saying how load balancer is able to handle millions of requests. So load balancer is a very lightweight application. There is no business logic written in the load balancer. For example, you want to fetch data from DB and you want to check something and assign it back. There is no such activity happening. There is only one simple logic of getting the request and forwarding it to the right server. Only that logic is written in the load balancer, which makes the load balancer highly optimized for I/O and horizontal scaling. So you can see here in this example, for large scale applications there are not only just one load balancer, there can be multiple load balancer. So these load balancers are also horizontally scaled. Okay, so this is one. And load balancers are so on the closing lines, load balancers are essentials for building scalable and reliable systems. Yeah, thank you.